Hi there, future leaders of artificial intelligence. Welcome to Anodium, education that enlightens. In the last video, we have spoken about the fact that nerves are responsible to transmit an external stimuli from an input sense organ and into the brain. In this current video, we will discuss about how actually the nervous system makes sense of the input stimuli. Say we are seeing a picture with our eye and the impulse is carried through the nerve into the brain. The structural unit of the nervous system is a neuron. Neuron consists of its input section or the dendron, the body or the soma, the tail section or the axon, and one neuron is connected to the next one through a link called synapse. And these neurons are structurally organized one after another along the length of the nerve. So this is about the structural side of the nerve and the neurons. How about the functional side of it? What does each neuron do? So each neuron definitely passes information linearly from the previous one to the next one. But any conductor can do that. Each neuron at its own small level performs a mathematical decision making called its activation. And through the collective activation of all the involved neurons, we understand the meaning of the input stimuli. So when we see a smiley with our eyes, the brain understands that we have seen a smiley. A frowny as a frowny, or a winky as a winky. Let us now investigate this a little bit more closely. Say somebody is looking at a winky. An image of the winky will be created at the retina of that person. An optic nerve will carry the same stimuli into the brain. The neurons that are responsible for viewing the lips will carry a pattern like this. The neurons that are responsible for the open eye will carry a pattern like this. The set of neurons which are responsible for the closed eye will definitely carry the features of the closed eye. Together, the neurons that are responsible for the eyes pattern will carry these features. Finally, at the visual cortex, this kind of a pattern will be passed on as the expression. And the brain will come to know that we have seen a winky. So we are moving from the retina to the brain, that is from left to right or from the input to the output. And this is called a forward propagation that helps us make sense of an input stimuli. When we see smileys, few neurons carry the smiling lips expression, few neurons carry open eyes, and together they carry this pattern, and the final expression in the brain at the visual cortex is like this. The moment we see a frowny, the lips get reversed for those neurons responsible for the lips. Both the eyes are open and the final expression is like this. So every time we are moving from left to right or input to output or sense organ to brain to make sense of the input stimuli. Overall, external stimuli is carried to the brain by nerves that are made up of neurons, and each neuron not only passes impulse but also performs a mathematical function at its own level called its activation. And collectively, with the activation of all the neurons, the nervous system makes sense of the input. So this is all done as per previous learning. We will talk about learning in the next video. Thus, through forward propagation, the network of neurons makes sense of the input stimuli. Enter neural network. Once properly trained with patterns of previous data and then given some input parameters, it can make sense of it or perform a certain task. So, an artificial neural network consists of artificial neurons, and your entire artificial neural network is a big mathematical equation converted into a programming object that sits in the memory. And each of these nodes in your artificial neural network are actually artificial neurons that pass information from the previous to the next layer and does some nonlinear calculations called its activation. The activation at the artificial neurons in the artificial neural network are very similar to the biological neurons, but they are way simpler. Even then, collectively, an artificial neural network can make sense of the input given to it. At this moment, one has to admit that the way nature functions is way more complex and sophisticated than the mathematics or the programming that we can actually do right now. Till then, scientists have not actually 100% definitely found out how the biological neuron actually works, but some groundbreaking research is being made to make an interface between the computer and the brain. Some organizations are trying to make a chip that will be implanted into the brain tissues of people with motor ailments and will be able to move machine parts or devices through their thoughts. And this is going to be really groundbreaking. Thank you. Thanks for watching. We have just entered into neural networks. Stay tuned. If you found this video informative, do give us a like. Do not forget to subscribe and share. Thanks again from anodium.com, education that enlightens.